Hello class, it should be Thursday, and today we're going to take a look at our first factoring unit, or the first day of the factoring unit. Now, this is a new unit, so in your notes this is going to be section 5, so for this do 5A, and the date of course today is 3/8/12, okay? So, don't worry about the table of contents today, I'll do that when I get back, but I want you to write that in your notes for today. So please get your notes out and we're going to take a look at factoring. Now, as we go through this, I'm going to have your substitute pause this video once in a while so that you have a chance to write some things down that I don't take the time for you to write down. So today's factoring is going to have 3 things. GCF is the first one, difference of squares is the second one, and then sum or difference of cubes is the third one. While we're doing the work, what you're going to do is I'm going to go over topic number 1, which is GCF. And then once I'm done on the board, we're going to pause the video and I'm going to give you some time to work on that in class. Okay? Then we're going to go on to the next one and then the third one after that. So if you don't have worksheets, if we could get worksheets passed out to everybody. Now on the worksheet, the front side, which is the one that doesn't have any X's on it. The back side has a couple of X's for problems that you don't have to do. On the front side, when we do section number 1 in your notes, then we're going to stop and I'm going to give you a couple of minutes to do section number 1. If you finish before the time is up, please flip over to the back side and get to work or help somebody around you that needs some help. That's probably an even better idea. Okay. After the first section, we're going to move on to the second and then to the third. And then anything that we don't get or anything that you haven't finished yet, you'll be able to finish either at the end of class or as your homework. So let's get to work. Greatest common factor. The GCF of 2 or more terms is the largest value that can evenly be divided by all of the terms. Now, the largest value means the thing that you're going to remove or divide from the problem. Okay? Now, we're going to use GCFs for polynomials. So what we're going to do is we're going to take different polynomials and look at the GCF. Okay? Now, the GCF can be both numbers and variables as you go through. So this first one has 2 numbers, 18 and -24. The GCF is the largest thing that can divide both of those numbers. What do you suppose that is? Okay. If you answered 6, you would have gotten it correct. So we're going to take out a 6. Now, how you take out a 6 is you bring that 6 to the outside of the parentheses. Okay. And then to figure out what goes on the inside of the parentheses, you're actually going to divide each part by 6. 18 divided by 6 gives me 3x squared, and -24 divided by 6 gives me -4. Okay? And this is what it looks like to factor. What I have done is I have taken something, 18x squared minus 24, and I've separated it into its different factors. When you have something that's separated, that means that you have factored it. Okay? Now, in addition to numbers, variables can also be used for the GCF. If we look at number 2, what's the number that can divide both of those? If you said 3, good job. Now, what's the variable that can divide both of those? Okay. Now, when you divide by a variable, you can't divide by too much. If you look at x to the 3, that has 3 x's. If I try to divide x by 3 x's, I'm going to run out. I don't have enough. Okay? So I can only divide by 1x here to get rid of everything. So I'm going to divide by 1x, and then I'm going to see what's left over. Okay? 3 divided by 3 is 1, and then 3 divided by 3 is 1, and then x to the third and x to the 1, I subtract my exponent, so I get x squared. You can either write 1x squared or just x squared. Then, -6 divided by 3 is -2. And x divided by x, 1 minus 1 is 0. And anything to the 0 power cancels out. So we get that. Okay, I've now done the GCF of that one. Okay, let's take a look at number 3. Now, number 3 has 3 terms, but we still do it the same way. First, we're going to do the number. What's the largest number that can divide all 3 of these things? Okay, hopefully you said 4. So we got 4. What's the largest exponent that can divide all 3 of these things? That's going to be x to the 3rd power. Now, notice x to the 3rd power is the smallest exponent. And you're always going to do the smallest exponent, because if you get one bigger than that, you're going to run into problems when you actually get to this exponent. So, I'm going to do my division. Now, you don't have to write out this division every single time. Most of the time, I don't write out the division. I just do it in my head. Okay, so we go up here. 12 divided by 4 is 3. And then we have 9 minus 3 is 6. So we have 3x to the 6th. And then the next one. 4 divided by 4 is 1. 5 minus 3 is 2. So it's x squared. You can either do 1x squared or just x squared. Okay? And then the last one. Negative 8 divided by 4 is 2. And it's minus 2 because of the negative sign. And then x to the 3 divided by x to the 3. 3 minus 3 is 0. Remember, you subtract your exponents. An exponent of 0 cancels out, so I don't have to put anything. I'm done with that one. Okay, I have one left on the bottom. Let me slide this up so that you can take a look. Okay, and why don't we have the teacher pause this so that you can try this one on your own. Notice this one has x's and y's, so you're going to have to figure out the x and the y. Pause it and I'll come back. All right, now, first the number. I'm going to divide all of these things by 5. That's the biggest thing that will divide them all. Okay, and then x's. My smallest x is x squared. So I'm going to divide by 5x squared. And then my smallest y, I have 2 here, 4, and y to the 1. So it's just y to the 1. Then when I divide, I'm going to get everything inside of the parentheses. Okay, so I'm going to do my divisions. The first one, 25 divided by 5 is 5. And x's, I have x to the 1 power. And then y's, I have 2 minus 1 is y to the 1. So I have 5x to the 1, y to the 1. Okay? And then plus, now I do this one. 15 divided by 5 is 3. And then my x's, 2 minus 2 is 0. That cancels out and goes away. Then my y's, 4 minus 1 is y to the 3. And then the last one is the minus 40. Negative 40 divided by 5 is negative 8. And then I do my x's. X, I have 5 minus 2 is x to the 3. And I have my y's. 1 minus 1 is 0, so that cancels out, and I get that. Now I'm done with GCF. I would like you guys to take 10 minutes to work on the GCF section on your worksheet. And then we're going to come to difference of squares. Okay, difference of squares. This is going to have to be paused so that you can write this down. Basically, for difference of squares, you're going to do 2 parentheses. And you're going to take the square of each term and put it into the parentheses. Okay? Now, what's kind of nice is the squares are pretty easy normally. And your parentheses look very similar. So first, let's do the squares. And to do the squares, you're really going to take the square root. If I take the square root of x squared, I get x. So I put an x in both parentheses. Then I do the square root of 64. The square root of 64 is 8. Basically what I'm trying to do is I'm trying to figure out what times itself will give me 64. 8 times 8 is 64. To get my final answer, what I need to do is I need to make one of these a minus and one of these a plus. And that's it. I'm done. This is a difference of 2 squares. Now, the one thing that is the most important thing about this whole deal of difference of squares is it is a difference. Difference means a minus. You need to make sure that this subtraction sign is there. If you ever see one with a plus, do not do the problem. There is no simplification. You can't factor it, okay? If it's a minus, you can do it. The square root of 144 is 12, and the square root of x squared is x. The square root of 100 is 10. So I'm going to do 12x and 10 in both parentheses. Now, in one parentheses, I'm going to put a minus, and in one parentheses, I'm going to put a plus, and I'm done. Okay? Let's do a couple of examples. I'm going to actually do this bottom example down here, this one, because it's a little bit different, and then I'm going to pause for just a second, have you guys do all the examples, and then I'm going to put them up here to see if you get them right. Okay? All right, for this one, I do my two parentheses. Okay? I do 100. The square root of 100 is 10, so I put 10 in both. Now, I want to talk about the x to the 4. What you do with exponents is you take the exponent and you divide it by 2. So if it's x to the 4, when I do 4 divided by 2, I get 2. So I'm going to get an x squared. Now, if this was x to the 10, let's say, I would do 10 divided by 2 and get 5 and put 5 in here. So basically, the exponent's divided by 2 every time. So I do x squared in both. Then the 64 is going to give me an 8. Y, because a y squared is going to give me y. And then 8y over here. I'm going to do one with a minus and one with a plus. By the way, which one has a minus and which is a plus doesn't really make any difference. Okay? Now, can you please pause it? I want to see you guys do each one of these, and then I'll do these to check. I just dropped my pen. I need to go pick it up. Okay, let's do each one. The first one is x plus 2, x minus 2. Again, the plus and the minus sign don't make any difference. I tend to change it for some reason. I probably should keep it the same way. But I'll do all of them with a plus. X plus 5, x minus 5. Okay. This one is 5x plus 1. By the way, this one can be tricky when there's a 1. If there's a 1, the square root of 1 is just 1. Okay? So anytime you see a 1, it's just going to be a 1 that's in each thing. Okay, this one down here is 6xy plus 2 and 6xy minus 2. This one is x plus 9 and x minus 9. This one is x plus 13 and x minus 13. And then the last one is 4x plus 7 and 4x minus 7. All right, now if you could do the second section in your on your worksheet, the difference of squares section. Difference of squares goes pretty quick, so I'd like you to take 8 minutes to do that section. Okay, the last one is sum or difference of cubes. Okay, now there's a trick to remembering this, and it's this over here on the side, C SOMAS. I'm going to say C SOMAS many, many times. C SOMAS, and it stands for this. So if we could pause the video so you could write that down, and then we'll go over what each letter means. Okay. Now, one of the things I do want to point out is that this is cubes. Cubes, you can do the sum or the difference. So this time, if I have a negative sign, that's great. But if I have a plus sign, that's great too. There's a difference between cubes and squares. For squares, if you have a minus sign, that's the only way it will work. Plus signs do not work. But cubes, both pluses and minuses work. All right, so here's how C SOMAS works. First off, you are going to make, notice it says C, cube root, first parentheses. You're going to do the first parentheses, and you're going to do this the same way you did the square root. You're going to figure out the cube root of each one of these things. Now, you can do a cube root in your calculator. One of the ways to do it is if you type in the 8 and then hit the up arrow and then do a 1/3 power. Okay? That'll tell you what the cube root is. So if you want to do cube roots quickly in your calculator, that's how you do them. Okay, there's other ways to do it in your calculator, but that's probably the easiest one. If you type this in, you get a 2. Okay? Then for exponents, the cube root, you divide just like we did for difference of squares, but this time, since it's a cube, you don't divide by 2, you divide by 3. 3 divided by 3 is 1, so it's x to the 1. Then minus 27. If you do 27 and then the up arrow to the 1/3, you get 3. And then z to the 6. 6 divided by 3 is 2, so you have z to the 2nd power. Okay? So this is your first parentheses. This is the c. That whole thing is c. You're going to take the cube root of the first thing, which is 2x, and the cube root of the second thing, which is minus 3z squared, and that's going to be your first part. Then from there, you're going to do SOMAS. Now, for SOMAS, you don't need this anymore. This can be gone from your mind. You're going to use this, and you're going to follow each of the directions. Direction 1 says square the first term. This is your first term. So you square it. 2 squared is 4. X squared is x squared. Okay? O stands for opposite sign. This is a minus. That means the opposite sign is a plus. Hopefully that makes sense. Then M is to multiply the terms. That's both of these terms here and here. I know I'm getting lots of arrows, but I'm almost done. Okay? That times that. Now, 2 times 3 is 6. And then these variables are different, so when I times them together, I need to write both. Z, or xz squared. Okay? And then AA means always add. So it doesn't matter if this is a minus or a plus. If this is a minus or a plus, this is always a plus. And then the second s down here is to square the second term. 3 squared is 9. This is z squared. When you square that, when you square something, you multiply exponents. 2 times 2 is 4, so we get z to the 4th power. Okay? That is C SOMAS. Let's look at a couple more examples. Okay? All right, now if you want to write down, instead of doing in your calculator, you can write this down. For example, that 8 that we did, if you want to do the cube root of 8, you just look over here and you see that 8's related to 2, so you'd put a 2. If you want to do the cube root of 27, you see that that's related to 3, and so on and so forth down the list, all the way up to 1,000. You probably won't see any in this class bigger than 1,000, but if you did, you just use your calculator to do them. Okay, let's take a look at a couple of these. I might do 2 of these together, 1 minus and 1 plus, and then I'll let you guys do the other 2 on your own and just write the answers. So, we're going to do C SOMAS. Don't forget C SOMAS. 2 A's. C SOMAS. C is the cube root of both. The cube root of this first thing, cube root of 125, and again, you can always go back here. Cube root of 125 is 5. So you get 5. And then remember, for the exponents, we divide. 9 divided by 3 is x to the 3rd. Okay? We do 64. The cube root of 64 is 4. And then the exponents we divide. 3 divided by 3 is 1, so this is just z. So that's C. We take the cube root of both. And then SOMAS. Okay? We square the first term. This is the first term. We square it. We get 25. And then remember, when you square, you multiply the exponent by 2. 3 times 2 is x to the 6th. Opposite sign. Notice this sign is a minus because this sign is a minus. Okay, so this sign will always be the same. So over here, it's going to be a plus for the opposite sign. Then multiply. We multiply these 2 together. 5 times 4 is 20. My variables do not match, so I write both of them down. X to the 3rd, z. Then lastly, I always add, and then I square the last term. 4 squared is 16. Z squared is z squared. So I get it like that. Okay? All right, this one down here. Now this one's an addition one, so we're going to need to do addition. All right, now 216 and 512. Let's look at those. 216 is a 6. 512 is an 8. So I'm going to use those when I do that. Okay? All right. 216 was a, what did I say? I forget already. 216 is a 6. 512 is an 8. I'll try to remember. So I take the cube root of that. I get 6. There's a plus sign, so I do a plus sign. I take the cube root of 512, and I get 8. And then, remember, for cube roots, you divide. 9 divided by 3 is a to the third power. Then I go through, so that's C. Now I have SOMAS. SOMAS, we square the first. 6 squared is 36. We do the opposite sign. This time, since it's a plus, we're going to do a minus. Okay? M is to multiply. I multiply these together. 8 times 6. Excuse me. 8 times 6 is 48. Hopefully. My math is a little slow. 48a to the third. All right. Then I always add, and then I square the second one. 8 squared is 64. A squared, 3 times 2 is a to the 6. And I'm done. Okay? So that's C SOMAS for those two. Now, if you guys would try these other ones and see how you do, and then I'll write them on the board real quick. Okay, let's check your answers. Okay, so this one we have 3x minus 4y squared. And then, so that's our C. And then our SOMAS is 9x squared. Opposite sign, multiply, is 12xy squared. Always add, and then 16y to the fourth. Okay? This one down here, the cube root, we do 7d. 6 divided by 2, or 6 divided by 3 is 2. And then plus 1. Remember that a 1 for a square root is just a 1. A 1 for a cube root is just a 1. So we get 1. And then I go through SOMAS. SOMAS, square the first term. I get 49d to the fourth. Opposite sign, multiply. When I multiply 7d squared times 1, I get 7d squared. Always add the square of the second. 1 squared is just 1. And that's it. Now, I would like you to take 12 minutes on difference of cubes, but realistically, however much time is left in class, I would like you to work on difference of cubes, and then I would like you to work on the back side of the worksheet. The back side of the worksheet is homework and should be finished by tomorrow. Have a good day.